Kalimutan ko. Okay. So, nawala. Napuputol-putol yung aking internet. Wala tuloy. So, you have the cording factor or the pitch factor that is 0.924. So, available. So, if you want to check kung tama ba yan, so pwede natin gamitin yung alam natin useful na formula. So, you may also use fractional pitch. Ano yung kanyang 12 span? 9. Ano yung pole pitch? That is 12. That's per pole. I-multiply natin ng 90. So, dapat parehas lang din yan. Assigned 9/12 times 90 equal, so we have also the same answer, 0.924. Now, kung babalikan natin yung general formula ng ating pitch factor, paano natin gagamitin itong vectorial sum of EMF per coil over the algebraic sum of EMF per coil? So, let us consider per coil, para eksakto, per coil side. Alam natin, per coil, dalawa palagi ang side niyan, yung start at saka end. So let us consider, walang binigay sa ating magnitude ng EMF or generated voltage in this given conductor. Let us assume, mag-set lang tayo ng kahit anong value, walang problema, same answer pa rin ang lalabas. So let us consider the EMF generated here, sabihin na lang natin is 20 volts. No? So the generated voltage in this given conductor is 20 volts. So, ibig sabihin, parehas lang naman conductor yan, parehas silang exposed to same amount of flux provided by our magnet. So, therefore, pag kinuha natin yung EMF generated voltage in this end side ng ating coil, it should be 20 volts also. So, therefore, pag sinabi natin algebraic sum only represent, that is, you add the magnitude. So, algebraic sum, 20 plus 20, so 40. So, that is the sum of EMF per coil side. Dalawa lang naman palagi ang side niyan, start at saka yung end. Now, paano natin kukunin yung vectorial? Pag sinabi natin vectorial, you have to include the corresponding angle. So, dito tayo nag-start, itong reference natin. So, that is mar angle 0. So, supposed to be kapatid, para magkaroon ng full pitch, dapat itong ating end na to, kay slot number 13. Okay? Kay slot number 13 siya pumasok. So, ibig sabihin, yung ating magiging total slot dapat doon is 12. Para ito, ang angle na ulit is balik tayo sa 0 degrees. Kasi 180, nandun na siya sa half cycle. So, since hindi siya umabot kay number 30, so na-short siya ng ilang electrical degree. That is our Corbin angle, alpha. So, kukunin mo ngayon yung angle ng ating end coil or end side ng ating coil, that is with respect to the Corbin angle. Ito yung kanyang magiging angle. Kasi kailangan, para magkaroon ng full pitch, mag-end siya kay 13. So, kinapos siya ngayon ng ilang electrical degree. And that is our alpha. Kaya generally, kapag kinuha mo si pitch factor, mathematically, that is equal to per coil side, generated voltage per coil side, bar angle 0, plus you have the generated voltage per coil side, bar angle alpha. So that is the vectorial sum. Yung ating algebraic sum, so that is only 2 times the generated voltage per coil side. Kaya kahit anong maging generated voltage per coil side natin i-assign, so walang magiging problema. Pwede silang mag-cancel out. Kasi pwede natin ilabas yan, the generated voltage per coil side, quantity 1 bar angle of what? 0 plus 1 bar angle, ano si alpha? 45. That is the 14 angle. So, i-divide na lang natin kanino? Twice of the generated voltage per coil side. So, in this case, cancel ito. Kaya kung sinet man natin ng generated voltage is 20, magka-cancel lang naman. Kung sinet mo ng 10, so walang problema. No? So no problem, hindi affected yung ating pitch factor kung ano man yung isa-set natin generated voltage per coil side. So, cancel. Therefore, if you want to check, express the answer also in terms of what? Polar form. So, check natin, ano? You have one shift bar angle of 0. That is always the direction of the start ng ating coil. Plus, dalawa lang naman yung sides ng side ng ating coil, the start and the end. So, the end part always has an angle of what? According angle, which is 45. Divide natin kay 2. Express mo yung answer in polar form kung ano man yung magnitude, and that should be the Fording or pitch factor. Tingnan mo, it should be the same. So you have 0.924 also. So those are the three possible ways to measure the pitch factor for our given alternator. Nakuha ba, kapatid? Any question regarding problem number 1? Pero actually, mabilis lang isolve yun. So binalikan lang natin what are the different factors to be considered para in case na kapag binigay is the coordinate angle, alam natin kung paano kunin. Na kung binigay yung generated voltage per phase, alam din natin kung paano siya kunin. Okay, ano letter yan? It should be Ariba. Okay. So, iwan ko, no? Let us try to solve for number 3. So, number 3, calculate the distribution factor. So, how to compute naman yung ating distribution factor? O mas kilala natin as D. So, kapag kinuha natin si distribution factor, again, the general formula that is the vectorial sum of EMF per phase naman. So, vectorial sum of EMF generated per coil per phase. Sabihin natin, all that is per phase. So, sa baba, palagi algebraic. Alam natin kung ano difference between vectorial at algebraic, no? So, this is just algebraic sum of EMF per coil per phase. At alam natin, it should be less than or equal to 1. Mathematically, mas kakilala natin that your distribution factor, it is also equal to sine of the quantity n beta over 2 multiplied to n sine beta over 2. So that would be the formula or general formula for your distribution factor, wherein n, so usually tawag natin dyan is the coil group, or that is simply the number of slots per pole per phase. So ibig sabihin, so dun sa ating, kung meron tayong 3-phase, kung meron tayong 3-phase dyan, ibig sabihin, kada phases ba, dun sa ating kada phase, or kada pole pitch, kung tawagin natin, no? Yung ating pole pitch is the slots per pole. So tulad dun sa ating problem, previous problem, meron tayong 12, no? 12 na pole pitch. So alam natin kung 3-phase yan, so kada phase, meron tayong 3 conductor. So, or pagka 3-phase yan, meron tayong line A, line B, line C. So lumalabas dun sa ating pole pitch na yon, dun sa 12 total number of slots. So, ilan dyan para kay phase A, ilan doon para kay phase B, ilan doon para kay phase C. So, yun ang pinapanggit nito, number of slots per pole per phase. So, dito sa ating problem number 2, so kung babalikan natin yung ating slots per pole, 12, at meron tayong 3 phase. So, ibig sabihin doon, yung first 4 slots, allotted yun para kay phase A. Yung 8, this is allotted slots for coil B. Then yung 9, 10, 11, 12, that is these slots allotted for what? Coil C. So yun ang ibig sabihin nitong ating number of N or coil group. The number of slots per pole per phase. Ilang slot so that is the value of our N. Now, alam na natin si beta. Beta is the equivalent electrical degree per corresponding slots. So therefore, solving for your distribution factor, binanggit ng problem that for this given generator, we have 36 number of slots. Number of poles, and again, that is what? 3 phase. So what would be the distribution factor? So pag kinuha natin yung ating slots per pole, or that is the pole pitch, so that is only equal to, ano na naman itong ating, ay, wala yung ating, so slots per pole, so that is only 36 over 4, so you have 9. So, ibig sabihin, ano, per pole, it covers 9 slots. So, doon sa 9 slots na yon, dahil 3 phase tayo, so solving for N, ilang slots para sa phase A, phase B, phase C. So, lumalabas, our N, that is only 3. So, lumalabas, you have 3 slots allotted for phase A, another 3 slots allotted for coil B or phase B, then the last 3 slots, it should be allotted for what? Phase C. So, ito siya kapatid, ano? So, kung kukunin natin ulit, to me, this would be the corresponding slots. One, two, three, four, 5, 6, 7, 8, 9, 10. That's number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let us consider this should be 1 is 3. So therefore, yung first slots natin, this first slot, it is only allotted for what? Phase A. So let us consider, ito yung mga coil kay phase A. Putulin ko na lang. So let us consider, lahat yan ay kay coil A. So we have 3 coil per coil A. So sabi natin, this is 1 coil. Well, di ko na kinumpleto yung figure sa likod. Okay? Ito lang naman yung nahanap natin para alam natin na ibig sabihin ng 3. So therefore, yung yellow, so yung next 3 slots, it should be allotted for phase B naman. Hindi ka pwedeng maglatag or maglagay na conductor dyan na hindi para kay phase B. So this is for phase B. So yung last 3 slots, that is already for phase C. Okay? So yun ang ibig sabihin nitong N is equal to 3. So sa isang whole pitch, equally distributed yung slots na yan dun sa ating tatlong phases. So kung tatlong coil or tatlong slots for phase A, so dapat tatlong slots din para kay phase B. Then you have 3 slots also for phase C, RYT. Ano? So red, yellow, and blue. So that is also color coding for line A or phase A, B, and C. So therefore, we can compute now that the number of beta. So you have 180, i-divide natin din sa ating voltage, which is 9. So equal yan, no? 20. So every slots here, no? Every slots here covered by 20 electrical degree, or that is equivalent to 20 electrical degree. So wala nang problema, you will compute now your distribution factor. So you have sine the number of n, that is 3, beta is 20, divided by 2. So you have 3 sine 20 over 2. So we have now the final answer. Now, ito kapatid, for 3 case, so for 3 case, doon lang naman tayo may distribution factor kasi meron tayo yung 3 group of coil. Pagka single phase, wala tayong distribution factor. Automatic, isa lang naman yan. No? So automatic for 3 case, this value, yung numerator na yan, so mas mabilis, so that is always 0.5. Okay? So yung numerator, that is always 0.5. Kaya itong equation na to for 3 phase can be simplified as 0.5. I-divide mo na lang, you have your n, then sine 30 over n. Okay? So pwede mo siyang i-simplify as 0.5 all over n sine 30 over n. Kasi itong number of coil group or the slots per pole per phase multiplied by beta over 2 for 3 phase, this is always equal to what? This is always equal to 30 degree. So meron lang naman tayong distribution factor pagka 3 phase, pagka single phase. So distribution factor automatic, that is 1. Ibig sabihin, hindi siya distributed, instead concentrated lang kasi isa lang naman yung ating coil, that is only coil A or coil B or coil C. For single phase, automatic distribution factor is 1. Pero for 3 phase, so it should be less than 1. Kaya itong n beta over 2 for kaya alam natin sine 30 degree, that is only 0.5. Kaya kailangan mo lang kunin doon is n. So pwede mo nang gamitin itong equation na to. Same lang din naman ang lalabas sa sagot. So titignan mo, 20 over 2, that is 10 times 3, so 30. So sine 30 is that 30 over 3 is 10. That is just the same as 20 over 2. So the same lang yan. Okay? So ba? So this only 0.5, divide ko ng 3, sine of 10. So that would be our distribution factor. Ang lalabas yan, you have 0.958. So that should be the answer. Ang letter yan, so 0.958 or pwede na 0.96. So that would be our distribution factor. Okay, sir, paano po kunin yung vectorial sum of EMF per phase over the algebraic sum? So here, kapatid, we have ilan yung ating F3. Ibig sabihin, meron tayong 3 coil for phase A in its given phase. So therefore, kukunin natin ngayon yung summation of EMF per coil for phase A. Pag algebraic, magnitude only. Pagka vectorial, isama mo yung ating magnitude. So let us consider again, kapatid, the generated voltage here per coil side, ang tawag natin dyan ulit, so this is the generated voltage per coil side. So kapag kinuha natin yung algebraic sum, so kung ilan yung ating coil per phase, so itotal mo lang. No? Tulad dito, tatlo tayo. So 3 times the EMF per coil side, that is always the algebraic sum. Now, saan natin kukunin yung vectorial sum? So, kung dito, coil A, alam natin tatlong slot sila at ang pagitan ng bawat coil is ilan? Isang slot. Kada isang slot, ano ba electrical degree? 20. So therefore, ang magiging angle nitong ating second coil, that is whatever this equivalent electrical degree. So ilan yun? That is 20 kasi this is one slot only, which is equivalent to 20. Ito ating third coil na yan, ilang slots ang pagitan niya simula sa ating reference? Dalawang slots. So, dalawang slots, ilang electrical degree? So, that is 20. Nakuha ka ba? So, therefore, the corresponding distribution factor, KD, pwede natin gamitin ito as 1. Okay. Okay, bar angle 0 plus, okay, you have generated coil bar angle of 1 times beta plus 2 times beta plus so on and so forth up to a sub c s bar angle and minus 1 beta. So that will be our vectorial sum. I-divide natin what is n multiplied by a sub c s. Ako ba? Kaya at any given EMF generated per coil side, so pwede natin siyang i-cancel out. No? Ano mo natin? Pwede natin i-cancel out. So n minus 1, so that would be always last. So tulad dito, ilan yung ating n? So 3. So therefore, ito yung ating last. So ilang slots yung pagitan niya simula doon sa ating reference. Since ito yung reference natin, dyan tayo mag-start measuring electrical degree. So kung siyang reference, that is always at what? Bar angle 0. Kaya at this case, pwede natin sabihin, pwede kong i-factor out lahat itong EMF generated per coil side, magka-cancel out lang naman dito sa baba. So sa taas, meron lang tayo 1 bar angle of what? 0 plus itong second, ilang slots meron pagitan sila sa reference, isa lang naman. So this is 1 bar angle of what? 20 plus, since tatlo lang naman yung ating coil per phase, so per group, so therefore, yung last natin, that is n minus 1. So hanggang dito lang tayo, by 2. So therefore, this is 1 bar angle, dalawang slots ang pagitan nitong ating last coil ni A do sa ating reference. So 2 slots multiplied with slots or electrical degree per slot. So therefore, its given angle, it should be what? 40. So i-divide na lang natin ilan si n, so that is 3. Labas mo yung sagot, in polar form, dapat ang magnitude, it should be equal to this value. So yun, ibig sabihin ng ating distribution. So let us consider 1 bar angle 0 plus 1 shift bar angle of 20 plus 1 shift bar angle of 40. Sa baba, 3. Shift complex 3. So, kunin mo na lang yung magnitude equal. So, ba't ko pala? It should be 3, no? Yung sinabi ko po ang natindot. Yung parehas lang. So, 0.9598. So, it should be 6. Any question regarding this distribution and pitch factor? Kung paano nga ba kunin yan in terms of the corresponding winding, in terms of generated voltage per coil side, so you may compute our distribution factor. Okay? So, iwan ko si problem number 3. So, let us try number 4. So, pwede natin diretso dito na ito. Alam na natin kung paano kunin lahat ng winding factor sa ating alternator. So, the following information is given in connection with an alternator with total number of slots. So, let us consider 144. So the given synchronous speed at which its rotor operates, that is at 900 RPM. Turns per coil. So for the given turns per coil, so one coil contains how many turns? Meron tayo 6. Then the flux produced per pole, that is equal to, I think, 1.8 times 10 raised to 6. So times 10 raised to 6, so automatic yan, that is in Maxwell. Kasi si Weber, usually, mga point something or milli ang kanyang value. Pag Maxwell, so matataas. Okay? So I think this should be in Maxwell. Coil span. So the coil span, that is from 1 to 16, which conclude that is only what? 15. Okay? Tignan na natin. Full coil. So ano ibig sabihin ng full coil? Full coil represent only that the number of slots, it is always equal to the number of coil. Okay? So, number of slots, it is always equal to the number of coil. Dalawa lang naman yan, full coil at saka half coil. So, pagka half coil, isang slots from the term itself, half, kalahating coil. Pero pag sinabing full coil, isang slots equal to the number of coil, or the number of slots, it is always equal to the number of coil. That is full coil. Dalawa lang yan. No? Meron ka lang half coil at saka full coil. Pag half, from the term itself, isang slots, kalahating coil. Okay? So, ibig sabihin, kung ilan man yung slots mo, divide mo ng 2, that is the total number of coil. Ano yung ibig sabihin doon? Pero pag full coil, kung ilan yung slots natin, that is also the number of coil. So, tulad dito, meron tayong 144 na slots. Ilang coil lahat meron tayo? 144 coils. Since you have what? Full coil. Yun ang ibig sabihin nito. Full coiled winding, 3-phase. So this would be the corresponding data given for an alternator that is connected at what? Star or Y connected. So what is the voltage generated between terminals? So pag sinabi natin between terminals, saan yung ating Y-connected alternator? So let us consider, ito yung ating alternator dyan. So between terminals, sino ba yung magiging terminal ng ating Y-connected alternator? That is A, B, and C. So kapag kumuha tayo ng voltmeter at nag-tap tayo between terminal, let's say, between A and B, so lumalabas, that is what? The line-to-line voltage. No? So that is always line-to-line. Kaya pag sinabing between terminals, it is referring to line-to-line voltage. Nakuha ba, kapatid? So therefore, hinahanap natin dito sa problem number 4, what would be the generated voltage between terminals? It represents as the line-to-line or line value. So since Y connected, alam natin, this is only square root of 3 multiplied kanino? E per phase. So kung kukunin natin si E per phase muna, alam na natin yung formula. 4.44, pitch factor, distribution factor, frequency, flux, and you have the number of turns per phase. So isa-isahin muna natin, ano kapatid? Pag walang binanggit, no, kung ano yung frequency, alam na natin that the frequency, it is what? 60 Hz. So therefore, kakailanganin natin yung number of pole, no, para mag-sukat natin or mabilang natin ano ba yung kanyang pole pitch. Walang given na pole, pero binigay naman yung ating speed. So solving first for the given pole, so pole now, that is simply equal to 120 times the frequency over the corresponding speed. So ilan lahat ito, no? 120 times 60, divide na lang natin kanina, 900. So this should be the total number of poles, 8. So in that case, okay na tayo, no? Kunin natin slots per pole. Lahat yan, 144 over 8. So 18. In that case, kuha natin yung ating pitch. So, wala nang problema sa magiging pitch factor. Now, kunin pa natin si n. Ano value ng n? Divide na lang natin yan by 3 since we have 3. So, we have what? 6. Okay? So, you have now 6. So, in that case, wala tayong problema. Kunin natin yung ating pitch factor. Okay? So, pitch factor, since fractional pitch available na, coil span is 15, pole pitch is 18, multiplied by 90. So, meron tayong pitch factor. Sine of 15 over 16 tuloy, 18 rather. 9, pwede na siguro natin 6, 5, 9. Start ko na lang kay A. Next, distribution factor. So, meron na tayong N. Repeat yan. So, numerator is 0.5. N is 6. So, therefore, you have sine of 5. Inaagad yun. So, 0.5 divided by 6. Sine of 5. So, you have 0.9561. Start ko na lang siya kay B para diretso. So, 0.9561. So, wala nang problema. O, isa na lang pala, no? Wala pang given na number of terms. So, to solve for the total number of terms per phase, meron tayong 6 turn per coil. Since the winding is full coil that always represent the number of slots is equal to the number of coil, therefore, the total number of turns, it should be, we have 6 turns per coil and there are 144 coil. Per phase ang kailangan natin, so divide by 3. So, ilan yan? So, 6 times 144 divided by 3, 288. So, ibig sabihin, yung total number of turns per coil A or per kay phase A, 288. Kay phase B, ilan siya? 288 din. Kay phase C, 288. So, equally balanced lahat yan. So, since kapatid, meron tayong number of ilan yan, no? 18. So, 18 pole pitch. So, ibig sabihin, doon sa 18 na yon, yung 6 doon, that is 4.8. Kaya meron tayong 6 turns per coil. Okay? Kaya meron kang 6 turns per coil. Yung 6 turns na yon, yung first coil na yon, that is 4.8. Meron siyang 6 turns. Yung susunod na 6 na turn, para kay coil B naman. Yung susunod na 6 na turn, para kanina naman, kay coil C. Nakuha ba? So, no more problem. Pwede na natin diretso din ngayon. So, therefore, para straight tayo, the generated voltage line to line, since Y connected, is square root of 3 multiplied by E per phase. E per phase, 4.44 RMS value. So, ikaw na bahala mag-input ng KP, KD. Frequency is 60. The given flux is 1.8 times 10 raised to 6. Turns per phase, 288. Now, since the given flux is in Maxwell, you have to convert it into Weber, kaya I have the multiplier of 10 raised to negative 8. So, this should be the answer na hinahanap sa ating problem. The square root of 3 times 4.44, yung aking pitch factor ay na kay A, yung aking distribution factor ay na kay B, times 60 times 1.8 exponent of 6 times 288. Then conversion, Maxwell to Weber, I have to multiply by 10 raised to negative 8. So the answer should be in volts. So you have 2,209.16 volts. Pwede natin i-rounded off nearest to 10 digit. So this is approximately 2,210 volts. Yun ang hinahanap ng ating problem. Ayun. Anong letter? This should be at constant. Nagets ba? Any question regarding problem number 4? So that is only computing the generated voltage. Pag sinabing between terminals, take note, automatic line-to-line value. So iwan ko si problem number 4. So let us try number 5. For number 5, generator is rated 100 megawatt, 13.8. So rated. But actually, no, most of the given alternator, so pagka AC, MVA din naman sila, no? Nga lang, since kailangan natin sa real power, so pwede rin natin silang i-rate in terms of real power. So the rated power of our alternator, kaya niya magbigay up to 100 megawatts. So, ibig sabihin, at full load ulit, at full load, the rated power, it should be equal to its output power. Full load. So, rated, ibig sabihin, kaya niya, no, that would be the maximum power or the load na kaya niyang supplyan, no, under normal condition. So, ibig sabihin, at full load, so yung kanyang output or the load connected to it, it is equivalent to its rated value, which is 100 megawatts. Wherein its line-to-line voltage, so sino itong 13.8? So this would be the terminal voltage. No? The terminal voltage line-to-line. (13.8 kV) with operating power factor, which is 0.9. The effective resistance to ohmic resistance is 1 point. Sino yung effective at ohmic? Pag sinabi natin effective, it is referring to AC resistance o yung ating armature resistance of the given alternator. Pag sinabi naman natin ohmic, that is the DC resistance. So that is the value of K. So binanggit ng problem, this value is equal to 1.5. So bakit 1.5? Kasi alam natin, palagi mas malaki ang AC resistance. So si RA, that is effective, o itinatawag natin AC resistance. So kung RDC, from the term itself, so that is DC resistance. So always consider that AC resistance, it is always greater than kay DC resistance. No? Palagi malaki ang AC resistance compared kay DC. Sir, bakit? Kasi kay AC, kaya lumiliit or kaya lumalaki ang kanyang resistance, that is due to the effect of what? Skin effect. So bakit si skin effect? No? So si skin effect, that is the circuit phenomenon at which, due to high frequency, yung flow of electron, it is forced to flow only near the surface. So, hindi niya ina-allow na mag-flow yung electron doon sa pinakagitna. No? Doon sa pinakagitna ng ating conductor. Kumbaga, kung babalikan natin yung ating conductor, so that is circular in cross-section. So, supposed to be within the effective cross-sectional ng ating conductor. So, dyan lahat dapat merong flow of electron once na in-apply natin yan ng voltage. However, due to frequency, no? Sa DC, wala tayong frequency pinapansigan. Pero pagdating sa AC, because of the frequency, ano nangyayari? So, hindi na-allow yung electron na mag-flow dito sa gitna. So, lahat lang ng electron should travel near the surface. Kaya tinawag siyang skin effect. Kaya kung papansinin mo, yung effective area ng ating conductor, eto na lang. Ito na lang. Hindi nakasama itong gitna. Parang lumalabas yung ating conductor, naging hollow. So in that case, maliit na yung area compared dun sa initial na kumpletong area. Kaya pag kinuha mo yung resistance, alam natin, resistance is inversely proportional to the area. Kaya ano mangyayari? Tataas yung resistance kasi nag-decrease yung equivalent area at which electron flow due to what? Due to high frequency. So that phenomenon, it is known as the skin effect. Kaya itong 1.5, that is due to skin effect. Okay? Nakuha ba? So therefore, In order to obtain the ohmic resistance, para makuha natin itong ohmic resistance na yun, ito muna to, nag-perform tayo ng test. Anong klaseng test? So, nag-perform tayo ng DC resistance test. So, paano yung DC resistance test niyan? So, to perform DC resistance test, automatic dapat yung ating alternator syempre, shutdown. Naka-off position. So, let us consider Y connected lang tayo. Na pwede naman tayo mag-connect ng delta or Y depending on the application. Right, so hindi ko na isasama yung kanyang rotor since at DC resistance, naka-off naman yan. So, hindi siya naikot yung kanyang prime mover. At the same time, hindi naka-energize yung ating field winding. So, under DC resistance, one of the procedure used for DC resistance is, syempre, naka-off yan. Then, ano gagawin? Yung ating terminal, yung ating generator should be connected dun sa ating DC source. So, susuplayan natin kahit alin dalawa sa kanyang terminal, maglagay tayo ng DC voltage here. So, ito yung ating magiging VDC. Then, susukatin natin yung current supplied to the generator by this DC voltage. Naglagay tayo ng ammeter. So, ang susukatin yan is the current and this should be what? IDC. So, ano ngayon ang behavior ng ating alternator? So, since naka-off yan, yung generated voltage natin na ether phase, bali wala. Wala yan. So, shorted na lang ito. Shorted lang yan kasi nga, naka-off naman yung ating alternator. Now, ang source natin is DC. Alam natin, sa DC, ano behavior ng inductor? So, at DC, inductor is what? Shorted. So, this inductor, virtually, shorted din yan. So, wire na lang ulit yan. Ano? Therefore, ang meron lang ngayon dyan ay yung ating mga resistance. So, since DC tayo, itong resistance per phase ng ating alternator, kapag sinupply natin ng DC resistance under DC resistance test, so it would serve the equivalent DC resistance per phase. Makukuha natin ngayon dyan is what? RDC. Okay? So since for DC resistance, dalawang terminal lang naman ang connected sa ating battery, isang positive, isang negative. So yung isang terminal natin, para siyang disregarded kapag naka-wire yan. So for Y connected, ano mangyari? Pwede natin tanggalin ito. Okay? So ano magiging connection ng ating dalawang DC resistance? They are now connected in series. So lumalabas ngayon under DC resistance, kapag kinuha natin by Ohm's law, ang total resistance, series lang yan, that is equal to R DC. Total resistance, or that is the resistance measured between terminals. Between terminals. So that is 2RBC since they are just connected in series. And by Ohm's law, they should be equal kanino. Total voltage over the total current, which is the VDC over kanino. IDC. So makukuha natin ngayon kay DC resistance yung equivalent DC resistance per phase ng ating alternator. So lumalabas your RDC, it should be equal kanino? 1/2 of BDC over kanino? IDC. If the alternator is connected in Y. Now, pwede rin naman, there is an instant that your alternator is connected in delta, so this should be 3 halves of BDC over IDC. This is only true if the given alternator is delta connected. O ba? So, meron na tayo ngayon C. So, using the ratio of AC resistance or effective resistance to ohmic resistance, makukuha natin ngayon yung kanyang equivalent armature resistance. So, wala tayong problema doon. So, alam na natin kung paano kunin itong AC at saka DC. So, ano hinahanap ng problem? So, under DC resistance test, nag-connect tayo ng voltage equivalent to what? Ano voltage? 6 volts. Ano nakita natin current? 43.8 ampere. So, ano hinahanap? What is the percent resistance? So, alam natin kung sino yung percent resistance. So, nakuha natin sa transformer. So, that is always your RPU. Or, kung gusto natin percent resistance, i-multiply lang natin na 100%. Percent R. So, kung babalikan natin yung sa ating transformer, percent R, that is the actual resistance. Sino ngayon yung actual resistance natin? That is your AC resistance. Multiplied na lang kanino? MVA base, divide mo kanino? KB base squared, at saka na lang natin i-multiply ng 100%. Saan mo kukunin yung bases? Huwag nang binanggit natin last time. Pag walang binanggit, kukunin natin doon sa rating ng ating machines. Ano rating ng ating machines? Meron siyang 100 megawatts and operating 90% power factor. So, makukuha natin sila MVA base. Ano ang line-to-line voltage niya? 13.8. So, that should be our KV base. Ako ha? So, no more problem. So, pwede ko lang diretso yung kapatid. Percent resistance. Okay? Solving for the percent resistance, ano magiging value ni RA? So, your RA now, that is always equal to K R BC. Saan lang galing? Based on this given ratio. So, anong given value of K? 1.5. Saan natin kukunin si RBC? Since the given generator, may binanggit ba anong connection? Pagka wala, anong assumption? Kapag hindi in-specified kung Y or delta, the assumption, it is always Y connected. Okay? So that is Y connected. So therefore, this should be equal to 1/2 times DC voltage 6 over current for 3.8. So that would be our actual resistance. Multiplied, MVA base natin? Given ang rated power, MVA tayo, so to get apparent is real over power factor. Kaya yung 100 na mega, divide mo kay power factor of 0.9, MVA na. So that will be our MVA base. Ano KV base? Ano line-to-line voltage? 13.8. Naka-KV na. So divide mo lang natin na 13.8 squared. Saka na lang natin i-multiply na 100. Nakuha ba? So, yun na siya kapatid. Yung hinahanap natin, yung problem number ay 1% resistance. So, 1.5 times, you have 6 all over 2 times 43.8 na naman, times MVA base is real over apparent or real over power factor. That is the apparent. So, 30.8 squared. Tsaka na lang natin i-multiply na 100 equal. So, 5.99%. Pwede na natin consider this is approximately 6%. That should be the answer. Meron ba? Ayun. Ano letter? This should be baliktad. Nakuha ba? Any question regarding DC resistance test ng ating alternator? That is one way to perform DC resistance. So that is applying DC voltage. Now, pag resistance test lang, pag resistance test ang ginawa, so for resistance test, hindi sila gumagamit ng DC voltage at ng current. Anong ginagawa lang? Pag resistance test lang, si alternator naka-off. Off pa rin. Anong gagawin? Kukuha lang ng ohmmeter. So, itatap lang si ohmmeter any two of the terminals. So, pwede itap niya kay line A, kay line B. Makukuha niya si RT. Ibig sabihin, by measuring, gagamit ka ng ohmmeter. Pwede niyang itap kay B at saka C, RT. Pwede niyang itap kay C at saka kay A. So ngayon, dapat yung tatlong reading ng iyong ohmmeter equal dapat yon. However, minsan may konting discrepancy. Kaya ang ginagawa, to get the total resistance, that is the average ng tatlo. I-average mo yung tatlong reading. Yun ngayon ang gagamitin mong total resistance. So therefore, pag meron ka ng total resistance, so i-apply mo na ngayon ito. Di ba? Ito si total resistance. Kaya kung Y yan, 1/2 of the total resistance. Kung DC, kung delta yan, 3/2 of total resistance. So that is another way to determine what would be the resistance per phase of your alternator, either applying DC voltage or by just measuring using ohmmeter. Okay, so iwan ko si problem number 5. Let us try number 5 ulit. Another 5. 5, di ko napansin. 5.2. Single phase synchronous generator delivers 90 ampere at 80% power factor. So what is the percent regulation? So kunin natin yung equivalent circuit per phase na lang. So let's say kunin natin si line A. So naka-Y, lakas mo sila, that is Y. So connected to ground or sa neutral, then there should be its corresponding synchronous impedance kung tawagin. That should be its armature resistance and synchronous reactance. So this would be our terminal A. So dyan tayo magpo-connect ng load. Sabihin natin, kuha tayo ng per phase load. Y connected also sa ground. So this would be our load. Therefore, the voltage available at the load side is B per phase kasi ito yung terminal. So this is terminal voltage per phase. The generated voltage per phase, you have what? A per phase. Then we have now the corresponding line current, which is A. So lumalabas, the armature current, it is equal to load current kapag kinuha natin yung kanyang equivalent circuit per phase. Tama ba, kapatid? So therefore, using our equivalent circuit, pag nag-KVL lang tayo dyan, makikita natin that the generated voltage per phase can be also computed as what? B per phase plus you have the armature current multiplied by synchronous impedance. But take note, this should be done vectorially added. No? So pag vectorially, yung ating A per phase, its given angle, it is usually as delta, represented delta, and your B per phase, usually, that should be our reference, kaya angle 0. Yung ating armature current, its given angle, either plus or minus, whatever the power factor. Alam na this given delta, ang tawag din natin is the power angle. Si power angle kasi, that is the angle between generated voltage per phase and the terminal voltage per phase. No? the angle between hyperface at saka hyperface. And since your hyperface is always our reference, so therefore, kung anong lalabas na angle ng hyperface, yun agad yung tinatawag natin power angle o yung ating delta. Nakuha ba? So therefore, kapag kinuha natin yung voltage regulation, alam na natin kung anong formula ng voltage regulation. Isa lang naman yan, general formula for voltage regulation. No load minus full load over full load. No? So, ang tanong na lang dyan, sino ba yung ating no load? So, pag sinabi lang natin no load, tanggalin lang natin ito. Okay? So, take note, the voltage regulation should be computed per phase value. So, pag no load, tanggalin lang natin ito. I-disconnect niyan. At saka tayo mag-measure ng voltage. Yan. So therefore, dahil no load, current is zero, so yung drop dito sa ating synchronous impedance is very much negligible. So sino masusukat natin yan? That is only what? E per phase. Nakuha ba? So your no load voltage, P no load, it would represent your E per phase. So therefore, pag pinuha natin yung full load voltage, pag full load voltage, syempre full load, connected yung ating rated load. So kapag same terminal, sukat tayo dyan, sinusukat natin. That's only beta phase. So this would be your beta phase. Kaya ibig sabihin, for your alternator, the percent voltage regulation, it should be equal kanino? Beta phase minus beta phase over beta phase multiplied by 100%. Okay, kuha? So in that case, wala na tayo magiging problema. So since single phase naman yung ating alternator, so automatic na naka-per phase tayo. Ngayon, nagbigay ng voltage. So sino ngayon ito? Take note, yung voltage na ibibigay ng problem unless otherwise, no, hindi binanggit kung terminal ba to o si generated, no? Kung si AG ba or si DT. So alam naman natin, unless otherwise, it should be the terminal voltage of your alternator. So lahat ng ibibigay ng voltage sa'yo, that is the terminal. Kung single phase, yan agad yung per phase natin. Kung three phase yan, ito yung line to line. Ano ha? Line to line terminal voltage. Kung three phase, since this is single phase, so alam mo natin that the D per phase, the terminal voltage per phase for this given alternator, you have 2,400 volts. So you have the armature current, IA, that is 90 ampere, with operating power factor equivalent to 1.8. Pag hindi binanggit, automatic, it should be lagging. Lagging dapat yan. So you have the synchronous impedance, which is 0.04 plus J 1.8 ohm. So what would be the percent regulation? So kakailangan lang natin interface muna. Next, so solving for interface. D per phase, anong value? 2,400 siyang reference, angle 0. Plus, armature current, given ang magnitude 90, ano magiging angle? Negative, since lagging, are cosine of 8. Multiplied, synchronous impedance. Ano synchronous impedance? Given na, no? So that is 0.04 plus J 1.8. So you have now the given value. Okay? So 2,400. Oh, dinig pa ako? Yun, bumalik. I-stack up. So 2,400 angle 0 plus You have 90 shear for angle negative. Arc cos of 0.8 times 0.04 plus 1.8 I. So let us just express the answer in complex number. Kailangan natin yung magnitude. So you have now 2,503.3 na lang. Ano angle? 2.92. So degrees, volts. So this angle, ito ngayon yung ating power angle delta in case hanapin. Right? So therefore, kuha na natin your percent voltage regulation. It should be equal to 2503.33 minus 2,400. Divide mo na lang by 2,400 times 100%. So that should be the answer. The shape of answer minus 24 over 24 times 100. So 4.31%. Yun ay nahanap natin. 4.3 will do. Anong letter? This should be Ariba. Nakuha ba? Any question regarding problem number 5.2? Itanong ba kapatid? Ito sa ating percent voltage regulation. Now, yung last na binigay ko kay transformer, pwede rin naman natin gamit yan, no? So, paano ko rin yun? No? So, kung babalikan natin, percent voltage regulation, pwede rin naman ito. You have the power factor plus percent R squared plus reactive factor plus minus percent X squared minus 1. Okay? So, your percent R, that is just 5A Yun. Umalik. Wala, nadi-disconnect yung aking isa. Okay. So, percent R at this case, for alternator, that is just the voltage drop across the armature resistance. Divide mo lang kay B per phase. And the percent X, that is the voltage drop across synchronous reactance over B per phase. So, pwede mo nang gamit yung ating form sa ating transformer. So, kung i-check natin, let us try to counter-check kung parehas ba ang lalabas na sagot, no? Para diretso. Para hindi ka na lang mag-compute ng interface, no? Kung hindi naman kailangan yung power angle. So, pwede mong gamitin yung diretsong formula na yan. So, alam mo natin sa power factor, 0.8 plus. Given naman kasi yung armature current. Given na rin naman yung ating armature resistance, 0.04. Kaya i-divide mo na lang yan na given 2,400. Squared plus. So, 8.8 yung power factor, sigurado, 0.6 is the reactive factor. No? That is sine of arc cosine of 8. So, lagging, so pag lagging, plus tayo. It should be plus 90 times 1.8. Divide mo na na 4. Quantity is squared. After nun, square root, then minus 1. At saka ka na naman multiply ng 100% sa dulo. So, check natin kung parehas lang yung lalabas na sagot. So, square root of 0.8 plus 90 times 0.04 1. Ay, so minus sa labas, 1 equal, at saka mo multiply ng 100. The same lang din. So the answer would be also 4.31%. Ay, nga lang, ang pinagkaiba, your percent R is IA times RA over B phase. Percent X is IA synchronous reactance over B per phase. So, pwede nyo rin gamitin ito para diretso ka lang, para hindi ka na mag-compute pa ng E per phase. Nakuha ba? Any question regarding problem number 5? May tanong ba, kapatid? Any clarification? May tanong ba tayo diyan sa first part ng ating alternator? Alright, so kung wala tanong, let us have a short break. Merienda muna tayo, kapatid. 15 minutes. 15 minutes will do before natin i-continue dun sa remaining part ng ating AC machine. So, merienda muna tayo, kapatid. 15 minutes. After that, Okay, good morning. So let us continue. So let us try number 6. So for number 6, generator at no load operates at 61.2 hertz with slope of 1 millihertz per watt. Load 1 of 1,200 watts and load 2 of 900 watts. Find the frequency before and after adding the load flow. So let us consider now for problem number 16. So given at no load, so at no load, the frequency of the given alternator, that is 61.2 hertz with the slope of 1 millihertz per watt. Ano ibig sabihin ng kanyang slope? So kung babalikan natin yung parallel operations of DC generators, no? So pwede natin kunin yung kanilang external characteristics o yung kanilang straight line characteristics. So alam natin, once the given load of your machines increases, so definitely kahit pa paano, may changes dun sa kanyang speed kasi nabibigatan yan. Alam natin, speed and frequency are proportional to each other. So therefore, kapag pignat natin yan, pwede rin makita yung kanilang straight line characteristics. So, kung binanggit natin, the y-axis, that is the axis for frequency. Kung frequency given, or voltage, pwede. And the horizontal axis is the axis for load. No? That is the axis for power, in this case. So, at no load, so ibig sabihin, so at zero, yung ating x-axis, so the frequency is at no load frequency. So, this would be the no load frequency. So alam naman natin, as load increases, so definitely, speed decreases. So mabibigatan yan. So therefore, speed and frequency are proportional. So kapag pinlat natin, yun yung binabanggit ng straight line characteristic. Okay. So let us consider, ito yung kanyang rated power. Natin. So this would be its rated power and this should be its corresponding frequency at load. So you have now the straight line characteristic. So kapag kinuha mo itong slope na to, alam natin, yung slope ng ating line, kapag slanting to the left, it should be negative. So this slope represent the change in the given frequency per change in corresponding output power. So binigay yan, this slope is equivalent kanina 0.1, not 0.1, 0.001 is milli, 0.001 hertz per watts. Ano ibig sabihin yan? So since this is slanting to the left, this given slope represent its frequency decreases by 0.001 hertz if the load connected to your alternator or to your generator increase by 1 watt. No? Kada increase ng 1 watt in the given power, the frequency reduces by 0.001 hertz. So therefore, from no load, nag-connect tayo ng two corresponding load. So first load, its given value is 1,200 watts. So sabihin natin, ito yun, ano? So we have P1, at this case, the load connected is 1,200 watts. So kapag kinuha natin yung kanyang frequency, project natin yan, so ito lalabas na frequency. F sub 1. Now, after natin i-connect si P1 or you have a load of 1,200 watts, i-connect naman natin si load 2. Alam natin, load is just additive. So therefore, let us consider at this case, the output power of your alternator, it is already what? 2,100 watts. Kasi connected na yung ating load 1 at saka load 2. So power is just additive. So, kunin natin ulit. So, kung sa tama, ito ngayon yung kanyang operating frequency. And let us consider f sub 2. So, yun yung hinahanap ng problem. What would be the operating frequency of this given alternator before natin i-connect si load 2? Before we connect load 2, ilan yung kanyang output? That is 1,200. Ano frequency? So, that is F1. And after adding, after natin i-add si load 2, ilan yung power? 2,100. Ano frequency doon? F sub 2. So, yan, nahanap natin F1 and F2. So, tulad ng binanggit ko last time, doon kung naalala pa yung ating DC circuits with parallel operation, which is just similar here. Ano ginamit lang natin dyan? That is only similar triangle, no? So, gagamit lang tayo ng similar triangle. Nasaan yung similar triangle natin dyan? Unang-una, ito ating original triangle, no? So, this angle and this angle and this angle are just not equal. So, kapag gumamit tayo ng tangent, so tangent of this original triangle, no load minus no load, naalala, no? So, you have no load, kasi frequency dyan, over frequency at full load, over 10, no? Rated power, it should be equal to frequency no load minus whatever the frequency over the output power. Now, kung papansinin mo, this is the change in Y and this is the change in X. So, ibig sabihin, this should be equal kanto slope. Now, kaya binigay ito, slope na to, kasi hindi binigay kung ano yung rated power and the frequency at full load instead, given sa atin yung slope. Kasi yung change in Y over change in X that represent the change in frequency over the change in power, that is actually the slope of this given line. So, wala tayong magiging problema. So, if this is P1, this is F1. If it's P2, this is F2, which is always equal to the slope. Okay, so kuha na, solving P1 or F1, so anong lumabas? So, you just cross multiply, then transpose. So, kita natin, your F sub 1, it should be equal to frequency no load minus slope multiplied with corresponding power. Anong power dyan? That is your P sub 1. Okay na? So, frequency of the load, 61.2 minus 0.001 multiplied 1,200. So, this will be the operating frequency before adding 900 watts of load. So, 61.2 minus 0.12001 times 1,200. So, you have 60 hertz. Okay? So, therefore, solving F1 and F2, so then, so therefore, same formula, F2 no, is frequency no load minus is load multiplied by P2. 1.2 minus, ano na yung final load, 2,100. So, you have the answer. Equal, so 59.1 hertz. So that should be the required answer. So 59.1 hertz and 60, anong letter yan? So this should be valid. Kaya nga, meron tayong ginagamit. No? Since alam natin, based on these characteristics, kahit pa paano affected talaga yung frequency at speed when the load changes. So therefore, kaya nga ginagamitan natin ng mga pang-regulate ng speed para pag nakasynchronize na yan, so hindi sila mawala sa pagkaka-synchronous kasi isa requirements for synchronous operation of alternator, synchronization, or that simply parallel is same frequency. So, para hindi siya mawala sa pagkakasynchronize with the other alternator or with the bus bar, so kailangan yung kanyang frequency hindi magbago kahit magbago yung load natin. Kaya meron tayong ginagamit na equipment, tools, no, para ma-maintain or ma-adjust yung speed at mag-maintain or to regulate the given speed. To regulate the speed, you may also regulate so, mga ginagamit natin doon, kaya meron tayong tinatawag na governor. So, governor, that is instrument or equipment used to regulate the corresponding speed of our alternator, no, para hindi siya mawala sa pagkaka-synchronize. Nakuha ba? Any question regarding problem number 6? Number 7. So for number 7, we have now induction motor. So sa induction motor, para hindi ko na lang i-draw yung kanyang equivalent circuit, so each circuit is approximately equal, approximately the same with the practical transformer. So yung kanyang circuit is similar to the practical transformer. Yun ang kanyang equivalent circuit kasi induction ulit, there is no electrical or physical connection between the rotor and the stator. So yun nga lang, dun sa ating practical transformer, so di ba you have the primary and the secondary winding. So the primary winding represent the stator and the secondary winding represent the rotor. So kung babalikan na lang natin, yes, may naka-on mic, yung na nakita. Okay, so for equivalent circuit, yung primary winding ng ating transformer represent this stator ng ating induction motor. So this would serve as the stator. So you have the, sabihin na lang natin, this is R1 and this is X sub 1. So that is at the stator. You have your E1. So that is the supply voltage at the stator. That is induction motor. Or sabihin na lang natin is B1. So take note, yung ating equivalent circuit is naka-per-piece, ano? So this would be our stator current that is considered I sub 1. Then we have its secondary. So the secondary represent its rotor. So pinagkaiba lang naman dito, wala tayong makita electrical or mechanical load sa ating secondary. Ay lang makita natin secondary for your induction motor. So this is the rotor of our induction motor. Anong meron yan? This is the rotor. So this is R2. And this is X sub 2. And this is your E sub 2. Then the rotor current. That is I sub 2. R2, X sub 2. And this is I2. So, this is rotor voltage. Rotor voltage at standstill. So, pag sinabi natin at standstill, hindi pa umiikot yung kanyang rotor. At standstill, ibig niya sabihin, its given speed is 0. Kaya ito, rotor voltage at standstill, and this would be the rotor reactance at standstill. So for this given induction motor, so its equivalent circuit, it is similar to the practical transformer. So for this induction motor, meron tayong two corresponding speed na kina-considered. So meron tayong synchronous speed. So synchronous speed, so NS, that is equal to 120 multiplied by F over T. So this would be the frequency. Sabihin natin F sub S, So this is the source frequency. So alam natin, induction motor is AC motor. So therefore, yung ating source, that is also AC. So you have the equivalent frequency. So ibig sabihin, kung ito is AC, therefore, the resulting current here, it should be also AC. So tinatawag lang, this synchronous speed, that is only the equivalent speed, no, of the given magnetic field in the stator. Kasi magnetic field, proportional yan kay current. No? That is the flux. So since current is alternating, so the given magnetic field, it is also alternating. So kapag kinuha natin yung equivalent speed produced by the or the equivalent speed of the rotating magnetic field in the stator, that is our synchronous speed. Or pwede natin sabihin, that is the equivalent speed at which this given voltage is being generated, which is used to supply the induction motor. Now, we have also the rotor speed. Kasi alam natin, rotor is the rotating part. So, pag sinabi natin rotor speed, this is always the actual speed at which the motor rotates. So, let us consider that is NR. So, that is the rotor speed. That is the actual speed at which this given motor rotates. At alam natin, this rotor speed, kapag kinumpare natin sa synchronous speed, so this is always less than. So, bakit siya less than? Kasi nga, ito yung ating rotor. So, mechanical side yan. So, due to its own weight, kahit pa paano, mabagal yan compared sa equivalent synchronous speed. So, rotor speed, it is less than the synchronous speed. Now, kapag kinuha natin S minus NR, yan tinatawag natin slip speed. Slip speed, that is the difference between NS and R. Kaya kapag kinuha natin si slip speed with respect to our reference, sino yung reference natin ngayon dyan, that is synchronous speed, yun yung ating tinatawag na percent slip or simply slip S. That is NS minus NR. I-divide natin ito na NS. So that would be our slip. So using the slip or percent slip of the induction motor, pwede natin sabihin that your NR, that is simply equal to 1 minus S multiplied to the synchronous speed. Or simply, dito na lang, NS, ilan mo siguro, NS multiplied to 1 minus S. So that is the relation between the synchronous and the rotor speed of a given motor. So dito, hinahanap lang synchronous speed of this given induction motor. Ito na pala yun. So direct substitution tayo. So for number 7, synchronous speed would be equal to, so solving for NS, ito lang yun. You have 120 times the source frequency, which is 60 cycle per second, 60 hertz, i-divide na lang natin ilang po yan, 6. So therefore, this is only equal to 1,200 RPM. That should be it. Now, ito rin ang makikita natin, no? So since alam natin, we have two different speed to be considered for AC motor, for induction motor. So, pag hindi binanggit, no, pagka walang specification ng speed na yon, automatic ang assumption that is the rated speed ng ating motor. Pag sinabi natin rated speed, that is the actual speed at which the corresponding motor rotates during full load, which is referring to rotor speed. So, yun palagi ang assumption. And at the same time, ang behavior ng synchronous speed, your synchronous speed, that is usually divisible by hundreds. No, kung nasa thousands and above yan, ang kanyang value always divisible by hundreds. So, ibig sabihin, it always ends with 2 zeros. So, kapag nakita mong speed end with those 2 zeros, automatic synchronous speed yun. Kasi yung rotor speed, no? Kumbaga, ito yung merong butal, may gansal. No? Hindi siya exactly divisible by hundreds. But synchronous speed, it is always divisible by hundreds. Siya. Okay? So yun ang relation between synchronous and rotor speed of this induction motor. So number 8. Tulad yan, a 3-phase 4-pole induction motor is rated to 20 and 1,745. So tulad dito, hindi binanggit kung sino yan. Sabi lang is rated speed, rated voltage and speed. So that is the rated speed. It is automatic rotor speed. This actual speed at which the given motor operates during full load. So rotor speed yan, ano? So ito 1745 rotor speed. So kung synchronous yan, dapat itong last 2 digits zeros yan. Okay? So dapat yung last 2 digits zeros para masabi natin synchronous speed. But in this case, this should be rotor speed. So meron tayong 4-pole, 3-phase, and its rotor speed that is 1745 RPM. What is the percent slip? Okay, so percent slip or simply slip. So that is S. Alam na natin yung formula. We have the rotor speed. So kailangan natin si synchronous. So alam natin, kapag wala binigay na frequency, we have to consider what? 60 Hz. So kapag pinumpute natin si NS, we have 120 times 60. I-divide natin ito nito. 4. So lalabas, this is 1,800 RPM. Right? So in that case, no more problem. Slip now, that is 1,800 minus 1,745 over 1,800. Ilan yan? 1,800 minus 1,745 over 1,800 times 100. So it should be 3.05%. So yun ang hanap natin final answer. 3.05 or 3.1. So that should be the answer. Okay? Nakuha ba? Now, since NR is less than to your NS, but definitely, ang kanilang value hindi nagkakalayo yan. No? Hindi nagkakalayo ang value ng NR at saka ng NS. Palagi magkalapit yan. So therefore, ang technique diyan para hindi ka na mag-compute ng NS, kung given si NR, dahil alam natin NS is always divisible by hundreds, which means itong last 2 digits is always 0. So ang gagawin mo na lang kay NR, let's say ito yung ating NR, ano? Given sa atin si NR, 1745. So para mabilis mo makuha si NS, automatic, ito, 0, 0 yan. So next, dahil malaki si NS compare kay NR, ano yung kasunod ng 17? Next number kay 17. So mag-plus 1 ka na. So that is 18. So that is already your NS. Palagi nyo. Okay. Ganun lang palagi. Pagkuha ng NS no, para mabilisan. So kasi si NS, approximately, no? NS and NR, hindi nagkakalayan. Pagkalapit lang palagi. So since exactly divisible by 100, so your 2 digits, cancel mo kay NR, palit ka ng 0, then yung 2 remaining, mag-add ka lang ng 1, that is already your NS. Okay, po ba? So I want to see problem number 9. Number 8. So number 9, the speed of induction motor, so therefore that is NR. RPM. What is the frequency of the rotor starter? So required frequency of the rotor starter. F sub R. Since AC yan, alam natin, the current in this rotor, this is the rotor current. So this is also AC. So what would be its corresponding frequency? Okay? So balikan natin ito para tingnan natin ano ba behavior ng ating motor. So kung babalikan lang natin ang behavior ng ating rotor frequency, so your rotor frequency, it is always proportional kay slip speed. So dyan, nakabase yung ating rotor's current kay slip speed. So therefore, alam natin kapatid, diba ko muna ito. Okay? So, palitan natin ng equal sign yan. So therefore, the rotor frequency that is K, something naman yun. So this is NS minus NR. Yan palagi ang general expression ng ating rotor speed. So paano natin kukunin yan? So let us go back dun sa ating induction motor. Puntahan natin kung ano ang kanyang behavior. So let us consider at standstill. At standstill, ibig lang sabihin, your NR is 0. Okay? So, ibig sabihin, hindi pa umiikot itong ating motor. Parang sinabi natin at standstill, that is at starting. So, at standstill, NR is 0. The behavior of your induction motor, that is the same as your transformer. So, the behavior of your induction motor, it is also the transformer. So, therefore, pag kinuha natin yung rotor voltage, ano equation do sa ating transformer? Diba? 4.44 frequency, flux, and the number of turns. Alam natin, 4.44 is constant. Let us consider flux is constant. At number of turns, it is just simply constant. So lumalabas, the rotor voltage is up to is the rotor voltage at standstill. No? So the voltage, it is just directly proportional to no? Frequency. At alam naman natin, your reactance, it is also proportional kanina frequency. Tama ba? So your reactance, it is also proportional to frequency. For kapatid, pag kinuha natin ngayon yung ating rotor frequency at standstill, NR is 0. So anong lumalabas? That the rotor frequency, sabihin natin, at standstill, S, it is now only equal to K multiplied kanino? S. Tama ba? Eh, alam natin, kapatid, that the frequency at the stator, ano frequency sa stator? Pag kinuha natin yung frequency at the stator, it is equal to K, huwag na lang doon, no? O para makuha natin mas mabilis. So, ito nga binanggit natin, at standstill, the operation of your induction motor, it is just simply equal kanino? Practical transformer or simply transformer. Since NR is 0, so the rotor frequency at standstill, it is now only Ks. Eh, alam natin, kapatid, since at standstill, this is transformer, ano ba behavior ng transformer? Diba, ang transformer, it is used to transfer electrical energy from one circuit into another at what? Constant frequency. So, ibig sabihin, what is the frequency in the primary? It should be the frequency at the secondary. That is also the same as the frequency at the stator. It should be equal to the frequency at the rotor. So, ibig sabihin, at standstill, the rotor frequency, it is just equal kanino? Stator frequency. Kasi ang behavior niyan, that is only transformer. Nagets ba kapatid? Constant of frequency. So lumalabas is only K times S nakuha. So therefore, at normal operation or simply at NR, it is no longer 0. Your rotor frequency, that is equal to K multiplied NS minus NR. Therefore, pag kinuha natin ang ratio ng rotor frequency during normal condition and during standstill, ano makikita natin? So, i-divide na lang natin kay rotor frequency at standstill, which is only K and S. So, pag dinivide natin yan, kapatid, since iisang motor ang pinag-uusapan, this constant is cancelled out. Anong nakita natin? That the ratio of the rotor frequency over the stator frequency, it should be equal ns minus nr over ns. Sino yan? So that should be equal to s. Kaya lumalabas your rotor frequency, it should be equal to s times f of s. Okay? Kaya ano ibig sabihin? So since the voltage, the rotor voltage proportional to the frequency and reactance is proportional to your frequency, so same also, kunin natin yung ratio ng kanilang rotor voltage during normal condition with respect to standstill and rotor reactance during normal condition with respect to standstill. So makikita natin that the rotor voltage over the rotor voltage at standstill, which is equal na lang yan kanina, S multiplied kanina, F sub R. Okay? I-divide natin kanina. Yan. Ang ba't na isip? Ito lang ito. That is F sub R over F sub S. Tama ba? So therefore, F sub R in terms of F sub S, ano na lang matitira? So you have only S kasi F sub R is S times F sub S. Rotor voltage during normal condition, the frequency is rotor frequency. The rotor voltage during standstill, its frequency is F sub S. Kaya nung lumalabas that your rotor voltage at normal condition is S multiplied kanino is up to. Same also with this reactance. So the rotor reactance during normal condition over rotor reactance at standstill equal proportional kay rotor frequency over it is again equal to S. Kaya makikita natin, rotor reactance, it is equal to S multiplied by X of 2. Kaya kapag simplified natin yung ating rotor circuit per phase, no? So the rotor circuit per phase, makikita na natin that with the corresponding source voltage, this is the rotor voltage, which is equal kanina S multiplied by 2, and you have the rotor resistance, and you have the rotor reactance. So yung rotor reactance natin, this is now equal to S multiplied kanina rotor reactance at standstill, and this is your R2, at ayan yung ating current I sub 2. Kaya kung kukunin natin yung current, rotor current by Ohm's law, voltage is S multiplied into, i-divide lang natin sa impedance, which is the operations of your induction motor during standstill, kaparehas lang siya ng transformer. Same behavior as the transformer. However, during normal condition, so meron konting changes dun sa ating voltage and the rotor reactance, since these two are just proportional to the frequency. Kaya kung naalala natin yung formula, ito lang talaga yun, direct substitution. So binalikan lang natin kung saan nga ba nakuha ito relation na to, that the rotor's current, it is always equal to percentage slip multiplied by the source frequency. Kaya pwede na natin diretsuhin. So given for problem number 9, you have NR, NR that is 1,170 RPM. Therefore, kung kukunin natin si NS, kaparehas ang ginawa na kanina para mabilis, tanggalin ko yung dalawang digits, gawin ko 0, 11 plus 1. So NS, it should be now 1,200 RPM. Kinaagad yun. So therefore, makukuha na natin yung ating frequency at a rotor. Pag walang binanggit na frequency at stator, automatic, our assumption that is 60 Hz. Therefore, rotor frequency, it should be equal 1,200 minus 1,170 divide 1,2. That is the percent slip multiplied by 60. So, meron tayo sagot. Yan lang ang solution. Times 60. So, we have the answer. 1.5 Hz. So, tama lang, mas maliit yan. No? Maliit talaga ang rotor frequency. So, we have 1.5 Hz. So, ang letter, so this should be valid. Okay? Any question regarding problem number 9? So, iwanan ko si number 9. So, let us try to solve for problem number 10. So, for number 10, a 6-pole 50 Hz 3-phase induction motor running at 950 RPM has a rotor copper loss of 5 kilowatts. Its mechanical power of 3-phase, so yung ating rotor copper loss, so that is RCL. Okay? So kung naka-per phase tayo, per phase lahat. No? So the rotor copper loss per phase, it is equal to 5 kilowatts. So what would be the mechanical power developed or the rotor copper loss of 5 kilowatts? So what would be the mechanical power developed? So hindi ko babaguhin yung symbol. Mechanical power developed, that is the RPD. Rotor power developed. So yun ay nahanap. You have the RCL and you have the RPD. So para makuha natin yan, balikan lang natin, no? Although direct substitution to, pero mas maganda, balikan natin yung power stages of induction motor. Okay? So motor pa rin yan. So that should be electrical to mechanical. So therefore, yung ating input is electrical. Saan ba yung ating input side? The input is always at this stator. Kaya ang tawag natin sa power input, SPI. So SPI stands for stator power input. So kung 3-phase, so that is 3-phase power formula. So sabihin na lang natin in terms of 3-phase, so this should be square root of 3 line-to-line voltage at the stator current multiplied power factor at the stator. Okay, so kung naka-per phase yung ating equivalent circuit, so this is 3 V1 square root of 3, alam natin that is 29. Okay? So after that, hindi lahat ng ating electrical power is converted into mechanical power. So una natin tatanggalin lahat ng electrical losses kay stator. Okay? So tatanggalin natin lahat ng electrical power kay stator or lahat ng losses sa stator. So unahin na natin dyan yung tinatawag natin SCL. Ano si SCL stands for stator copper losses. Okay? So kung naka-per phase tayo, that is I1 squared multiplied kanino R1. So R1 is per phase resistance at the stator. So kung ito-total natin yan, times 3. Kung 3 phase. Kung single phase, tanggalin mo yung 3. Okay? Yun ang tatanggalin natin. And also, tatanggalin na rin natin yung ating SIL. Okay? Sino si SIL? SIL, S is stator, I is iron losses or the core losses. Then, sino yan? That is again, the hysteresis at saka si eddy current. So, yan lahat tatanggalin natin kay stator. After natin tanggalin lahat ng losses kay stator, papasok na tayo ngayon sa rotor. So, the power absorbed by the rotor, that is your RPI, rotor power input. Okay? So, that is now the power input to the rotor. So, dahil sa rotor na tayo, so this is now in terms of mechanical. So ngayon, hindi lahat ng rotor power or input power of the rotor is converted into useful mechanical. So meron tayong losses na tatanggalin doon. Ang losses na tatanggalin natin kay rotor, that is your RCL. Rotor copper losses. So rotor copper losses, nasa nyo, no? So para kita natin yung flow of power na yan, kunin ko yung circuit ng ating induction motor. So take note, this is per phase, ano? So this is rotor or stator resistance, stator reactance, stator voltage per phase, stator current per phase. So we will have now the rotor. So this now already rotor voltage. So during normal condition, no? Isang R, alam natin ang value, which is S multiplied by SL2. And this is rotor resistance, and this is rotor reactance, which is S multiplied rotor reactance at standstill multiplied by V, you have the rotor I2. Right? So that will be the equivalent circuit ng ating induction motor. So this is the stator. Alam natin, this is stator side. And this should be the rotor side. So dito tayo ma-input electrical. So the power input here, that is the stator power input. So since this is per phase, kaya ito yun, 3 times V1I1 power factor of the stator. The stator supply voltage per phase, and you have the stator current. So therefore, yung input natin dito, dadaanan niya yung ating copper kay rotor. Kaya tatanggalin natin yung stator copper loss. So pag pinraise pa natin, dadaan tayo kay core. Kaya tatanggalin natin yung losses dito. That is the stator iron loss. So therefore, the current here, that is now the current induced in the primary winding, which is whatever the power here, ito na yung ipapasok natin kay rotor. Alright? Kaya nga, pag tinanggal natin itong power absorbed by the rotor resistance or stator resistance and the corresponding core, that is now the power available papunta kay rotor. So, yun na yung ating RPI. Okay, so andito na tayo. The power available here is RPI. So, ngayon, tatanggalin natin, dadaanan natin si R2. So, that is copper. Tatanggalin natin yung power dito. So, the power here is rotor copper loss. Since naka-per phase yung ating equivalent circuit, so using Ohm's law, this is simply I2 squared R2 kung 3 phase, meron tayong times 3. So that is the total rotor copper losses. So yung ating power develop, hindi natin makikita dito sa ating circuits kasi maliwanag, that is already mechanical. Okay? Hindi na natin makikita yung mechanical side dito sa ating circuit. Pero kung gagamitan natin ng konting mathematical approach, pwede natin express kung nasaan si RTD. So after natin tanggalin yung ating rotor copper loss, so the given power now, it is known to be the rotor power developed or the mechanical power developed, or that is the power available at the shaft ng ating given motor. So wala pa tayo sa output, so tatanggalin pa natin ngayon yung mechanical losses, the friction and windage. So si friction and windage, so dito, sino naman yung sinasama sa SPL? The friction and windage loss. So nandiyan lahat. Rotational losses. So si SPL or mechanical. So after natin tanggalin yan, so doon pa lang lalabas yung ating output power. So the output power is RPO, rotor power output. Okay? Ngayon, pagdating niya sa power stages, yung pinaka-critical side is ito. Yung ating RTI, RTD, at saka RCL. Most of the time, dyan umiikot yung tanong sa power ng ating induction motor. So, kailangan makita natin ano relation ni RTI, ni RCL, at saka ni RTD. So, tulad ng binanggit natin, yung power develop or mechanical power develop, wala na yan sa equivalent circuit. Kasi mechanical. Pero kung gagamitan natin yan ng mathematical approach, pwede natin kunin yung equivalent resistance that represent the power developed. So, paano yun? So, tulad nga kanina, pag kinuha natin si rotor current, ano yung rotor current? No? S multiplied kanina into over R2 squared plus 1. S x sub 2 squared. So, simplified natin ito. Palabasin natin yung equivalent resistance ng ating power developed. Anong gagawin? Multiply ko lang ito by 1 over S over 1 over S. Okay? So, anong natira? Cancel na yung S kay E2. So, therefore, we have now only sub 2 divide. Ngayon, ipapasok ko sa loob ng square root itong S nito. Anong lalabas dyan? Magkakaroon tayo ng R2 over S squared plus 1. X sub 2 squared na lang. Tama ba? So therefore, after natin i-multiply ito, lumalabas that the rotor impedance Z2, it is now equal to R2 over S plus J X sub 2. Diba? Ito yung kanyang rotor impedance. So therefore, pwede natin laruin ngayon ito. Kailangan ma-separate ko na lang itong rotor resistance. So itong R2 over S, gamitan natin ng algebra, it should be equal kanino? R2, okay? Plus R2 over S minus R2. Tama? Walang nagbago? Kasi R2 minus R2, 0. Babalik tayo, no? R2 over S. So, ginawa natin yun para mahiwalay natin yung mismong rotor resistance. So, nung hiniwalay natin yung rotor resistance, we have another resistance. So, this resistance, it is the equivalent resistance of what? Power developed. So, lumalabas, ito siya ngayon. You have R2 plus J X sub 2 plus i-simplified natin ito. Factored out ko si R2. Meron ako ngayon 1 minus S over S. Tama ba kapatid? That is now the rotor resistance. So, ibig sabihin, pwede natin ngayong i-simplify yung rotor circuits. Pwede tayo ngayon magkaroon ng circuit na makikita na yung ating power develop. Sino na ngayon ito? T sub 2. Na-separate natin si rotor resistance at standstill and the rotor reactance at standstill. So, this is R2, this is X sub 2. Then, we have now additional resistance here. So, this resistance, it is now the equivalent resistance of power developed. which is R2 times 1 minus S over S. Sinong current pa rin ito? So that is S2. So ito siya ngayon. The power available here is your RPI. The power available here is RPI. So makikita mo lang si RPI, it is equal to P2 times I2 multiplied the power factor at the state4. So that is your RPI. Now, i-trace natin, dadaanan ngayon si R2. Tatanggalin natin sino? Yung ating rotor copper loss. After mong tanggalin si rotor copper loss, sino na ang makikita natin? This resistance. So the power absorbed by this resistance represent your RPD. So kasi ito yung equivalent resistance of the power developed. So lumalabas using power formula, RPD, it is anong current ang dadaan sa kanya? I2 squared. Ano resistance ng power developed? Si R2, quantity 1 minus S over S. Kung 3 phase yan, i-times 3 natin. Ako nga ba? So therefore, try to look for this given quantity. Tingnan mo ito. Sino yan? Diba? This is your RCL. Saan na ibig sabihin mo? Kaya kung naalala mo kapatid, ito lang talaga ang solusyon mo. RPD, it is always equal to RCL, quantity 1 minus S over S. Nakuha? That is your RPD. So, lumalabas na yun, kung gusto kong kunin si RPI using power stages, that is RPD, that's what? RCL. Kaya po, ito kapatid, isa-substitute natin dito, makikita natin ngayon that RPI can also express in terms of RCL. So, ito, substitute natin dyan. So, makukuha natin ngayon that RPI, it is also equal to RCL over S. Now, that is your RPI. Now, ano pa ang pwede natin makita ngayon? Tignan mo ito. So, sino yan? That is RCL over S. So, ibig yung pala sabihin, your RPD, it is also equal to RPI multiplied 1 minus S. So, ayan yung relation ng ating tatlo power sa rotor. Rotor power developed, RPI, and RPD. Kaya kung naalala mo lang ito kapatid, kanina pa siya tapos. So, ibig sabihin, RPD now, meron na tayong RCL. So, kakailanganin na lang natin sino? That is S. Saan natin kukunin si S? So, we have NR. So, alam mo natin si NR, alam mo na ngayon yung ating S. Okay? So, given na that NR, so for number 10, NR is 950 RPM. So, therefore, NS, tanggalin ko yung dalawang digit, 50, 9 plus 1, 10. So, this should be 1,000. RPM, meron tayo rotor copper loss of 5 kilowatts. So, makukuha na natin diretso yung ating RPD. So, kung lang muna natin si percent split na kailangan natin. No? NS minus NR over NS. So, ilan yan? 50 over 1,000 na lang. So, 0.05. Okay, so wala problema. We have already derived RPD. It is always RCL 1 minus S divided by S. So this should be only 5 kilowatts. Quantity 1 minus 0.05 over 0.05. So yun yung ating final answer. Yan lang talaga ang solution. 1 minus 0.05 divide natin by 0.05. So ilan yan? 95 kilowatts. Kung maalala mo na yung power sequence at relation ng RPD, RPI, RCL, so mabilis natin masasolve yung problem number 10. So anong letter ito? This should be Balta. So any question regarding problem number 10, no? The relation between these three given power dyan sa ating rotor. Iwan ko kapatid, let us try number 11. So for problem 11, the rotor of a 3-phase 60 Hz 4-pole induction motor ticks, no? Rotor ticks. So ibig sabihin, it should be the rotor power input. No? The rotor of this induction motor ticks. So the power absorbed by the rotor, so that is RPI. No? That is 120 kilowatts. Since naka-rotor tayo, so yung frequency na yan is rotor frequency, that is at 3 Hertz. Wherein source or stator frequency, that is 60 Hertz. Ano yung nahanap? Determine the rotor copper loss. Nakita na natin kanina that RPI, it is just simply RCL over S. So therefore, RCL, it is just simply the product of percent slip and RPI. Saan natin kukunin si S? So since given ang rotor frequency and stator frequency, you may have the value of what? S. So wala nang problema. The ratio of rotor frequency and stator frequency, alam natin that is automatically percent slip. So multiply mo na lang by RPI, which is 120. So ilan ito? We have only 6 kilowatts. Yun ay sagot. Anong letter? That's time. Ako ba? Any question regarding problem number 11? Number 12. For number 12, a 3-phase induction motor develops. So maliwanag. Motor develops, it is referring to RPD. So RPD, that is 15 HP. Ano yan? 3-phase. With percent slip, given na S is equal to 5% or that is 0.05. If the motor has secondary resistance, sir, ano po yung secondary resistance? Tulad nga binanggit natin, no, the winding of transformer para siyang sino? Si induction motor. Yung primary is stator, yung secondary sino? Si rotor. Kaya lumalabas yung secondary resistance, it is just referring to rotor resistance per phase. So this is per phase, no? Si R2. That is 0.075 ohms. Ano yung nahanap? What is the rotor current? So that is I2. Saan natin pwede makita si I2? Since power ang given, alam natin that RCL, it is 3 times I2 squared times R2. So, ibig sabihin, makukuha natin yung ating I2 kung alam na natin si RCL. Okay? So, saan natin kukunin si RCL? Alam natin, given that RPD, it is equal to no, RCL quantity 1 minus S over S. Meron tayong RPD. So, meron tayong S. So, makukuha na natin diretso yung ating RCL. RCL. Lumalabas that RCL, it should be equal to S over 1 minus S multiplied kanina RPD. Tama ba? So, ito na lang ngayon yung isa-substitute natin dito. Masosolve na natin si rotor's current. So, pwede ko nang diretsuhin. Lalabas na yun that the rotor's current ay 2. It is just simply the square root of RCL over 3 R2. Okay? So, kuha na, kapatid. You have the square root. So, S is 0.05. 1 minus 0.05. RPD, tignan si RPD, 15. Gawin natin watts. Kaya meron ako 746. Sa baba, 3 times si R2, 0.075. So, meron tayong rotor current I2. Okay? And we can check. 0.05 over 1 minus 0.05 times 15 times 746 to make it watts, divided by 3 times 0.0375 as the 0.075 lang. Equal 51.16 ampere. That should be our answer. 51.16, 51.2 will do. So the answer will be valid. Okay, ako ba? Any question regarding problem number 12, no? With respect to the rotor's current. So pwede rin sana by ohms, no? However, wala tayong reactance and wala tayong source voltage. Kaya the other way to solve for the rotor current is by using the formula for your RCL. Kasi doon natin makita yung ating value for rotor's current. Or pwede ka nang dumiretso doon sa ating RPD. Kasi alam naman natin, RPD, we have RCL, SRCL, ito na substitute, the same answer lang din naman ang lalabas sa ito. Okay? So, iwan ko si number 12, number 13. For number 13, a 20 HP. Sir, sino ngayon yung power niyan? So that is the rated output. That is the nameplate rating of your motor. So the nameplate rating represents the rated output of the given motor, which means that is the output or that is the load connected to your motor during full load. So at full load, this 20 HP, which is the rated output, it is now your RPO. Sabihin muna natin, ano? So rated power is 20 HP. Now, kapag sinabi natin at full load condition, itong rated power na yan, yun yung ating RPO, rotor's power output. So that is at full load condition. So 20 HP, 3-phase. So 3-phase tayo. So given yung supply voltage. So sino yan? No? Line to line. Sino yung line to line supply voltage natin? That is our stator supply voltage, which is BS. So, ilan siya? 440, no? Volts with the frequency at the stator of 60 Hertz. In the number of poles, that is only 6. As full load is speed, so that is operating at full load. Full load is speed, it is referring to rotor speed of 1,140 RPM. Kaya kahit hindi na natin compute si NS, alam natin this is 1,200 RPM. Mechanical rotational losses, sino yun? That is the SEM. No? The mechanical rotational losses is 300 watts. So dito kay induction motor, magka-separate, no? Hindi sinama kay SPL yung iron losses, no? SIL ang tawag nila dito. Pero diyan, si SPL, that is only the stray load loss, or that is the mechanical rotational losses, which is the friction and winding. So what is the electromagnetic torque? Of one, that is electromagnetic torque. Pag sinabing electromagnetic torque, it is just simply referring to torque developed. So, doon sa ating DC circuits, nakuha na natin yung formula ng torque. The same pa rin lang dyan. Hindi magbabago kasi same principle lang naman yan. No? Ang nagkaiba lang is in terms of the quantity, no? Sa DC at saka AC. But the principle, it will be the same. Kaya kung babalikan natin yung ating torque formula last time sa DC torque, it is equal to, sino to, no? 9.55 over the speed multiplied kanino? Power. 9.55, anong unit niyan? That is Newton meter. Yung isang torque, that is 7.04 Newton. That NS na N na lang. Speed, 7.04 over the speed multiplied by T. Anong unit niyan? That is also pound foot. So, yan pa rin ang gagamitin natin formula. Yun nga lang, babaguhin lang natin yung mga variables na gagamitin para alam natin we are dealing with induction motor. So, ibig sabihin, kapag hinanap natin si torque developed, the power to be considered, it should be power developed. Sino ba ang power developed? So, that is RPD. So, lumalabas, 9.55, ano speed ng motor? It should be the NR, that is the actual speed at which the motor rotates. So, pag torque developed, you have what? RPD. So, yun na rin ito. So, this is RPD and this is NR. So, you have the torque developed. Nakuha ba? Kung output torque, output power ito. Kung input torque, RPI ito. Nakuha ba? So, same formula. 9.25 over the rotor speed multiplied the corresponding power. So, that will be our torque. So, in that case, wala tayong problema. Since the operation of our motor is at full load, so at full load, the rated power is RPO. Since hinahanap ng problem is the torque developed, so alam natin, using power stages kanina, RPD, it is also RPO plus sino? SPM. Kasi wala tayong RCM, so hindi natin magagamit yung RCM. So since sinong given, RPO at saka SPM, so using power stages, kita natin kanina, RPD, it is also RPO plus SPM. So no more problem, kuha na. Meron tayong NR, so this is now direct substitution. So lumalabas that the torque now in Newton meter, it should be 9.55 rotor speed given 1140 multiplied, you have your RPO, convert HP into watts, 746. Plus na lang sino? 300. So therefore, the answer automatic in Newton meter. Yan ang hinahanap natin. Okay? 9.55 divide na lang natin 1140 times the 20 times 746 plus 300. Yan na yun. So, ilan siya? 127.5 Newton meter. So, that is already our torque developed. Kaya kung ang formula doon sa ating BC, parehas lang din naman dito. Nga lang, babaguhin lang natin ng konti yung mga variables para alam natin kung induction motor ba yan or AC motor ba yan or DC motor. Okay? So, 127.5 ay yung exact ko lang. Anong letter? That should be at cast time. Okay, kuha? Any question regarding problem number 13? So, iwan ko, no? Let us try to solve for number 14. What is the ratio of maximum to full load torque in a motor having a slip of 4% at full load and 20% at maximum torque? Okay, so let us consider at full load, The sleep at which the motor operates during full load, that is 0.4 or 4%. Ano? Tingnan natin. 4%. Now, that is at full load. Now, at maximum torque, hindi maximum efficiency, instead, maximum torque. So, at maximum torque, that is considered S sub M. That is the sleep at maximum torque, not the small letter sub M. So, that is 20%. So, ano ang hinahanap? What is the ratio of maximum torque over the full load torque? So, saan natin kukunin yan, kapatid? So, actually, para makuha natin yung formula niyan, nandun na naman yung term na maximum. So, ibig sabihin, ang derivation niyan ay gagamit talaga ng derivative. So, kung babalikan natin, no, balikan natin yung ating torque formula. The general formula for torque, that is always what? T-coil. No, dito na lang natin daanin. No? So, that is in T-coil. So, K, it is just constant flux, no? So, sa ating DC. Tama ba? T-coil. And this is the current. Now, sinong current ito? Since torque ang pinag-uusapan, siyempre, the current kung nasaan yung mechanical load. So, that is at the rotor. So, that is I2. However, alam natin, alternating itong motor current. So, ibig sabihin, meron siyang real component at saka meron siyang reactive component. Eh, si torque is real component. Kaya yung ating torque dito, dadagdagan lang natin ng cosine theta para makuha natin yung real component ng ating rotor's current. Sino to? The power factor angle ng ating rotor. Okay? So, therefore, kung kukunin natin ngayon yung ating equation, no, your flux, no? So, si flux, tama ba? So, alam natin, you have the corresponding motor. It is also the same as the transformer. Pag kinuha natin yung generated voltage, you have electric fan. Okay? So, for frequency is constant and number of turn is constant, so the flux is also proportional kanina kay voltage. Tama ba, kapatid? So, therefore, since from the equation E equal to 4.44 F flux M, so pwede natin sabihin voltage is also proportional to flux. So instead of flux ang gamitin natin, palitan natin to as voltage. Now yung rotor current kanina, the rotor's current I2, it is just S E2 over kanina. You have the square root of R2 squared plus kanina S x sub 2 squared. Tama. At kapag kinuha natin si cosine theta, this is the power factor at the rotor. Alam natin ang power factor is rotor resistance, rotor, or the resistance over the impedance. Ano impedance of the rotor? That is your R2 squared plus 1 S x2 squared. So kapag lahat yan, sinubstitute natin, so si I2, substitute natin doon, si power factor, substitute natin dyan. So, ito lalabas na general expression ng torque. So, torque now, it should be equal to K multiplied na lang kay S voltage squared. So, may voltage na tayo rito, may voltage tayo rito. So, naka-squared, multiplied ka na R2. Okay? So, sa baba, dalawang square root. So, you have R2 squared plus 1 S x sub 2 squared. Okay? So this would be the general expression for our torque. ng ating induction motor. So now, para mas simplify yung analysis, let us consider at voltage is held constant. Let us consider at E is constant, sino na lang ang pwedeng factor that would affect the corresponding torque? That is only your S. Kasi as load changes, torque changes. So pag nagbago si load, magbabago yung speed. Pag nagbago yung speed, magbago yung 6. So at E is constant, therefore, kung gusto nating i-maximize si torque, anong gagawin natin? We take the derivative of torque with respect kanino S, then equal to 0. So, eto makikita natin dyan. Hindi ko na siya i-derive. At maximum torque, to achieve maximum torque, eto makikita natin condition that the rotor resistance, it is only equal to S multiplied kanina X of 2. So, that is the condition to achieve maximum torque. So, ibig sabihin, kapag kinuha ko yung slip dyan, it represents the slip at maximum. So, this formula for slip, which is equal to R2 over X2, it is only applicable if the given torque is maximum. Nakuha ba? If the torque is maximum, yan yung ating slip R2 over X2. So, anong gagawin natin? So, from this given equation, if E is constant, pwede ko siyang i-simplify, ano? So, if E is constant, itong E na to, ipasok natin dito kasi constant. Constant times the constant is still a constant. Eh, alam naman natin, itong R2, that is also a constant. Hindi naman nagbabago yung resistance ng ating rotor. So, ipasok na lang natin dito kasi naka-multiply na. Kaya yung ating equation, that is only equal to K times S over R2 squared plus quantity S X sub 2 squared. Ito yung i-differentiate nyo with respect to S. Ito makikita mo. So, saan natin gagamitin yan? So, kunin natin itong equation na to. Kapag T sub M ito, S sub M ito. Pag T full load ito, this is S at full load. Kaya ito na yung ating magiging ratio, no? So, you have, kunin mo ratio ng T torque at max over torque at full load. So, in that equation, so meron pang K S sub M over R2 squared plus S sub M X sub 2 squared. For full load, it should be K S at full load all over R2 squared plus S at full load X sub 2 squared. So, gamitan mo ng algebra yan, hindi ko na isi-simplify, ito ang lalabas na value. Try mo i-derive, gamitan mo lang na algebra, simplified lang yan. It would be equal to a slip at full load plus a slip at maximum squared divide lang by 2 S at full load times S of M. So this would be now the ratio of maximum over full load. Okay? Kaya kung naalala mo yung formula, direct substitution yan. Kung gusto mong i-derive ito para hindi mo makalimutan, you try to simplify this equation. Ito ang lalabas. Algebra lang. Kayang-kaya mo yan. Okay? Kaya kung recall mo yung formula, kung kanina kasi tapos. Therefore, so, over the full part, it should be equal to slip at full load, kahit naka-percentage, okay na yan. Squared. Slip at maximum, 20 squared. Divide by 2 times 4 times 20. So, meron times 4. 4 squared plus 20 squared divided by 2 times 4 times 20. So, you have 2.6. That should be the answer. Ano ba? 2.6. Ayun. Anong letter? Valid that. Kuha? Any question regarding problem number 15? Nakuha ba, kapatid? Any question regarding that? So, pwede rin naman. So, doon sa torque develop, Kung ayaw mo dito daanin, so pwede mo rin idaan dito yung ating part develop kasi si N. So makikita mo, 9.55, ano si NR? And X quantity 1 minus S. Ano si RTD? RTD is 3, I2 is squared, R2 multiplied kanino? 1 minus S over S. Quantity is squared. So, pwede natin i-cancel ito at saka yun. Okay? Then, yung NS, constant na naman ito at saka 9.55, constant. Tapos, ito R2, that is also constant at saka ito. Now, ano si I2? Pag i-squared mo yan, ito si I2. So, si I2. Yun, di ba? So, pag in-squared natin yan, pag in-squared na ito, meron akong S squared, E2 is squared over squared nito. Eh, may S to. So, magka-cancel din yung isang S. Babalik tayo dito. Tama, kapatid. The same lang din yung lalabas na equation. Kahit saan mo idaan yung torque equation. Basta general expression ng torque, eto yun, kapatid. Now, if E is constant, if the voltage is held constant, mas simplified ka siya. That is only S over R2 squared plus SX squared. Okay? So, I want to see problem number 15. Number 14. So, let us try number 15. So for number 15, a squirrel cage motor develops a maximum torque, 2.25 times its full load torque. So the ratio of maximum over full load torque, it should be equal to 2.25. Its full load and standstill reactance. Sino yung standstill reactance? Binigyan natin, that is what? XL2, which is, based sa problem, 4 times its resistance per phase. So that's 4 R2. Determine the slip when working at full load. So yun ang hinahanap. What is the slip at full load? Okay. So, hinahanap sleep at full load. So, we have the ratio of maximum over the full load torque. Now, binigay yung relation no standstill reactance at saka rotor reactance. Eh, alam natin kanina, to achieve maximum torque, rotor resistance is equal to S times rotor reactance at standstill. Kaya, using this relation, makukuha natin yung slip at maximum torque. So, therefore, solving first is slip at maximum torque, which is always equal kanino. That is the rotor resistance over the rotor reactance at standstill. Retain natin si R2. X sub 2, that is 4 R2. So obviously, that is what? 0.25. Okay? Or 25%. Okay? So, wala nang problema. From our derived formula that Tmax full load equal kanino? S at full load squared plus S at maximum squared divided by 2 S at full load S at max. So, pwede na natin simplify. So you just cross multiply this value. So you have 2.25 times 2 times the required value as full load times 0.25 as full load squared plus 1. 0.25 squared. So pag simplified natin kapatid, 0.25 times 2 times 2.25. So we have now S full load squared. Transpose natin ito, magiging minus 1.125 S full load plus 0.25 squared equal to 0. Anong meron? You have now quadratic equation. So using our quadratic equation, pwede na natin kunin quadratic equation. Alam natin that is at mode 5, 3. So we have now slip at full load. So we have two possible value since quadratic equation. Yan, no? So ano labas? Mode 5, 3. So we have 1, negative 1.125, then 0.25 squared equal. So first possible value is 1.0664. The second possible value would be 0.0586. So alin ang nasa choice? So therefore, the final answer would be 0.0586. Anong letter yan? Arriba. Okay? So pares positive. Now, may nagtanong, sir, paano po kung nasa choices din si 1.0664? What if, no? What if na naman kung itong value to ay nasa choices? Anong magiging sagot? Although this value is available sa choices, but definitely this value is disregarded. Mathematically correct siya, but practically, theoretically speaking, tandaan natin that the value of your slip, it is always less than or equal to 1 only. Hindi siya pwedeng mag-greater than 1. The highest possible value of slip is only 1. Kailan siya slip is only 1, that is only at standstill. At standstill o yung tinatawag natin starting. Kasi at starting, the rotor speed is what? 0. Yan ang maximum value ng ating slip, which is only 1. Never, no? Malabo na maging greater than 1 yan. Kaya kahit ibigay ito sa choices, your slip cannot exceed 1. Okay? So, mathematically tama ito kasi mathematical operation tama siya. Pero practically and theoretically speaking, with respect kaya kahit ibigay ito sa choices, so hindi siya pwedeng maging sagot. Kuha ba? Okay? So, any question regarding that? So, I think that will do it for our generators and motors since parehas lang din naman sa DC at pinagkaiba lang, no? Alternating lang pagdating dito yung ating source and the output. Okay? So, any question regarding our AC machines? May tanong ba? May clarification? Sir, good morning po. May I ask lang po for any update if there any changes in the calculator being used with the board exam? Currently, wala pa rin changes. In terms of Casio, kasi karamihan sa estudyante is Casio. Sila familiar. Although may ibang unit, Sharp, yung iba pa. But basically, for Casio, 570 pa rin. Nakalagay doon, basta 570 edition, that is allowed. Wala naman sila nilagay doon na restriction na yung first edition tsaka second edition. Basta 570 ES. 570 ES. Ang hindi ko lang sure kung kasama ba yung EX. Kasi ibang edition na yung EX eh. Pero dati, sa civil engineering, may nakapag-exam na ang calculator is 570 EX. Okay? Kasi mas high-tech ng konti si EX compare kay ES. Pero yung second edition ng ES, yung kulay black, ES pa rin, no? Kung ES pa rin yan, no? Kasi may first edition, yung ito yung first edition, ganito itsura niya. Ganito itsura no first edition. Yung second edition, yung kulay pure black. That is pure black. So, yung second edition, since ES pa rin yon, pasok pa rin siya doon sa ating required calculator sa board exam. Ang hindi lang included doon, yung EX. No? Wala sa listing ni PRC yung EX. Pero kasi hindi pa siya ina-update. Wala pang lumalabas na updated doon. Or check nyo na lang kung ina-update na. Ang nakalagay pa lang din doon is Casio 570. Kaya in terms of Casio, si 570 talaga. Basta naka 570 siya, so alam po, pwede yan. Yan ang alam. Ngayon, doon sa civil, siguro, hindi lang na-check. Kaya in case, kung meron kayo ng EX na 570, kung meron kayo EX na 570, so much better, for sure na lang, dapat meron pa rin kayo ng 570 na ES. Para in case, kung nagamit mo na si EX, so unang dalhin mo si EX. Yung ES, nandun lang doon sa inyong envelope. So kung walang nag-check ng calculator, magagamit mo siya. Pero kung in case, may mag-check, sir, mali lang akong dampot. Kunin mo yung ES. Yun ang gamitin. So yun siya. Okay. Kasi na-key-board exam, na-key PRC is still 570. Yun pa lang din. Hindi pa siya nag-update ng panibagong mga units ng calculator. Yung dati pa rin. So check nyo na lang kung in-include nila yung EX. Pero alam ko, wala pa rin. Na-key PRC lang. Okay? So yun lang siya, no? 570 for Casio, yung sa Sharp at saka Canon, I'm not sure kung ano na yung kasi hindi ko ginamit si Sharp at saka si Canon. So, kay Casio. Pero pwede nyo tignan kay PRC. Na kay PRC rin naman.